Hello everyone, welcome back, and today we are looking at question 128, which is longest consecutive sequence. Now this question is interesting, and I think it was a hard difficulty and just became medium not long time ago. But I promise you, after this video you will see how simple this problem can get if you look at it from the right perspective. So let's get started. We are given an unsorted array of integer nums, and we want to return the length of the longest consecutive elements sequence. Now the catch is that the algorithm must be run in big O of n time, in linear runtime. So now step by step, what do they mean when they say consecutive sequence? What does consecutive means? Imagine that we have the numbers 1, 2, 2, 3, 4. Now a consecutive sequence means that each number in the sequence is followed by the immediate greater value. For instance, we go to the 1, we say, do we have a 2? As you see, the 2 is the immediate greater value from 1. Do we have a 2? We say yes, okay? Then we extend the sequence. When we are at the 2, we say, do we have a 3? We check, oh, we do not have a 3. So we stop here and we say, we have a sequence of length 2. Now we check the next value. Okay, so this new sequence starts at the value 2. We say, hey, do we have a 3? We go check, we see a 3. Now we say, do we have a 4? We check, yes, we have a 4. Do we have a 5? No. So we stop and we say, this is the next sequence. This is the second sequence with length 3. So this is what consecutive sequence means, alright? But now they are saying that the array is not sorted, and we want to find the longest consecutive sequence. For instance, looking at example 1, we see that we have the values 100, 4, 200, 1, 3, and 2. And they are saying that the longest consecutive sequence is of length 4. How is that? They are saying that the longest consecutive sequence is 1, 2, 3, 4. We have a 1, then we have a 2, we have a 3, and we have a 4. The array is not sorted, but we want to find the longest consecutive sequence. So the plan of today as follows. We will go to the blackboard. We will maybe have a small discussion about few brute force approaches we can get. Then we will go to the optimization, explain it in details, then come and code the solution out. If this sounds interesting, let's get straight into it. Here we are at the blackboard, and as you can see, I have wrote the same nums array containing 100, 4, 200, 1, 3, and 2. So a minute ago I was saying they are giving us an unsorted array, and we want to find the longest consecutive sequence. So you might say, what if we sort the array? Okay, so let's try to sort the array. If we sort it, we would get 1, 2, 3, 4, then we would get 100, and then we would get 200, right? We just sorted the array, and we can easily see that, hey, we have a sequence of length 4 here, we have a sequence of length 1 containing only 100, and we have a sequence of length 1 containing 200. Now this solution is nice, right? It's simple, straight to the point, but the problem is that any time you hear the word sort, you always think about big O of n log n. Anytime you hear the word sort, always think, hey, we must see n log n somewhere in the time analysis. So this solution is nice, but it's not fast enough. We want a linear runtime. So unfortunately, this solution cannot happen. Okay, so let's think about another way. What if we go to each number in the nums array and we check the sequence generated from that value? For instance, we go to the 100. So we start here, we say, can we find 101? And the answer is no, we can't find that. So we stop and we say, okay, we have a sequence of length 1. Alright, now we go to the next value, which is 4. We say, okay, do we find a 5 in the array? And the answer is also no, we cannot find a 5. So we have a sequence of also length 1 containing the value 4. So we go to 200 and we ask the same question, and we will get the same answer, as we don't have 201. So we have a sequence of length 1. Now we go to the value 1. Now the 1 is different. We go to 1, we say, can we find the 2? The answer is yes. so we type the 2. Can we find a 3? We check and we can indeed, so here is 3. Can we find a 4? We go and check and yes, we can find a 4. Okay, so can we find a 5? No, so we stop and we see that we have a sequence of length 4. So now we go to 3 and we say, can we find a 4? Yes, we can. Now we say, can we find a 5? No, so we stop, we have a sequence of length 2, and finally we check the 2 and we say, hey, we have a 2, okay, can we find a 3? Yes. Can we find a 4? Yes. Can we find a 5? No, we stop and we have a sequence of length 3. We check basically all the combinations of sequences and we take the greatest value. As you can see, we have the 4. Now, what is the time complexity of this? Now, we need to loop through the whole array, right? And because we want to check each number in the array, each sequence generated from each number in the array. So we need a for loop for that. Now, for each number, we want to search for the next value. When we are at 100, we started asking, hey, do we have 101? Or when we are at the 4, do we have 5? Or when we are at the 1, do we have 2? So this searching operation also needs another for loop. Now, when we find that value, we basically, okay, so when we are at 1, we say, can we find a 2? And we say, yes, we can. So we have a sequence, and now we want a while loop to see how long the sequence can get. But you can think of this approach as nested 3 for loops and the time complexity being O of n cubed. So this is much worse than this. Now you might ask me, why are you telling me this? Because this is extremely slow, right? Now I'm telling you about this approach because the optimization lies in this approach. This is extremely similar to the optimization, and that optimization will drop us from big O of n cubed to big O of n. Alright, so let's now explain how this big O of n can be derived. So let's see how can we drop this from big O of n cubed to big O of n. Let me draw a line and to make the visualization easier, okay? So we have this line and let's see why this big O of n cubed was so slow. Well, it was so slow because we were checking each sequence generated from each number in nums. We went to each number in nums and we were seeing, hey, how long the sequence generated from this number can be. We went to the 100 and we checked, we went to the 4, we checked, we went to the 200 and checked, we went basically through all the numbers in the nums. But this is slow. We want a way to basically know when do we need to check for a sequence. I don't want to go through each number in nums and see what is the sequence generated by this or that. No, I want a systematic way to check the sequence when I need to check the sequence. In other words, we only want to attempt to build sequences from the numbers that are not already part of a longer sequence. Let me say this one more time because this is the key to drop the time complexity to linear runtime. We want to build sequences from numbers that are not already part of a longer sequence. Let's look at an example to make things easier. So let me write these numbers on the line. So we said we have the 1, 2, 3, and 4, and we have the 100, and we have the 200, right? And let me write, put them inside of a box to make things more organized. So we have this, we have that, and we have this. Now, we just put 3 sequences, but how can we reach this point? Because as you can see, we are checking in the big O of n cubed a lot of things, a lot of sequences going on. But how can we know which sequences we need to check? Well, this is the key. We said we want to build sequences from numbers that are not already part of a longer sequence. What I mean by that is the following. When we go to the value 1, right, we need to check what is the immediate value that comes before 1. Well, the immediate value that comes before 1 is a 0. And we ask, can we find a 0 inside of the array? No, we cannot, okay? So this one will be the start of a sequence. Okay, but wait, let's check another one. Let's go to 2, for instance. Okay, we say, okay, we are at the 2. What is the immediate value that comes before 2? Well, it's a 1. Can we find a 1 inside of nums? Yes, we can. Then this 2 is part of a longer sequence. Because think about it. If we have the sequence that starts from the value 2, right? We would get this 2, 3, 4. We would get 2, 3, 4. But as I said, what is the immediate value that comes before 2? We said it's a 1. Now we said, hey, can we find a 1 in nums? And we said yes. So we have a sequence that is generated by 1. So we have this 1, and then we have the sequence generated by 2, which is 2, 3, 4. Which sequence is longer? This one, because this one is extra on it, right? We have 1, 2, 3, 4. So for each number, we need to check if that number minus 1 is present in the array. If that's the case, then I do not want to check the sequence that is starting from 2, for instance, because it is part of another sequence, right? And in this case, it's part of the 1 sequence. So, and this is what I mean by we only want to attempt to build sequences from numbers that are not already part of a longer sequence. So let's try to apply this. We go to the 1. Can we find a 0? Can we find a 0? What is the left neighbor of 1? What is the smaller value that comes immediately before 1? It's a 0. Can we find a 0? The answer is no. So we need to check the sequence that is generating from the value 1. So we say, hey, do we have a 2? We check, yes, we have a 2. Now, do we have 3? Do we have 4? Yes. Do we have 5? No. Then we stop. Then we have this big sequence that's generated from the value 1 and have length 4, which is right here. Okay? So now we go to the value 2. We ask the same question. Is 2 minus 1 present in the array? The answer is yes. 2 minus 1 is 1, and we can see that we have a 1 in the array, which means the 2 is part of the sequence that is generated by the value 1, and we can see the 2 is present indeed in the sequence generated by 1. So we skip the 2. We go to 3. Is 3 minus 1, which is 2, present in the array? The answer is yes. 2 is present indeed, which means 3 is part of the sequence generated by 2. As you can see, here is the sequence generated by 2, right? And 3 is present. So skip the 3. Same thing with 4. Is 4 minus 1, which is 3, present in the array? The answer is yes, so we skip the 4. As you can see, we only inspected the sequence generated from 1, and that's it. We did not go through this. We did not go through this. Now let's go to the 100. We asked the same question. Hey, do we have 99 in the array? The answer is no. So we have a sequence that starts from 100. So we need to inspect that sequence. Do we have 101? The answer is no. So we stop and we have a sequence of length 1. That's it. Here we have a sequence of length 4, of course. Now we go to the 200. We ask same question. Do we have 200 minus 1? In other words, do we have 199 in the array? The answer is no, which means that we have a sequence that is starting at 200 and we need to inspect that sequence. Okay, do we have 201? The answer is no, so we stop and we have a sequence of length 1. As you can see in this case, in this approach, we are skipping a lot of sequence, checking. We only check the sequence that is generating from a number that is not part of any other sequence. But now you might ask me, how can we check if the number minus 1 is present? Well, we need something fast, and for this we will use a hash set. The hash set provides a constant lookup time. In a sense, we will take all the numbers in the array, put them inside of the hash set, and now each time we need to check something, we ask the hash set. Hey hash set, do we have this n-1 in the array or in the hash set? The hash set responds and the lookup time is big O of 1. Now this approach basically drops the time complexity from big O of n cubed to big O of n. We will go through more details about the time analysis at the end of the video. But now let's go and code the solution out. Okay, I have split the screen. Maybe we can make, more explanations as we write the code. So we said we need the hash set because we need the constant lookup time when we look for the, n-1 as we just explained. So let's create, the hash set, and we have set. It will contain integers, of course. So integer, and let's name it, I don't know, hash set. So hash set equals new hash set. So we have created the hash set, and now we need to put all the numbers from the array inside of this hash set. So for each number inside of nums, so for int num inside of nums, we will add this number to the hash set. So hash set dot add this num. Okay, now we have put all the numbers from the array into the hash set. Okay, so now we need to loop through all of the numbers of the array, and we need to check, hey, do we need to check the sequence that is starting at this number or no? We need to check, is this number part of another sequence? And how did we say we're going to do that? Well, we said we need to check if this number -1 is not present in the array. Okay, so let's do that. So for int num inside of nums, we will say, okay, this num, can we find n-1 in the array? If the answer is yes, we need to skip this number because this number will be part of another sequence. If the answer is no, then this number is the start of a sequence. Look at this one. We will ask, hey, can we find 1 minus 1, which is 0? Can we find a 0 in this array? And the answer is no. So we know we will have a sequence that is starting at 1 that we need to check. Okay, so we are saying, okay, if the hash set does not, you see, if the hash set does not contain this num -1, then this number will be the start of a sequence that we are interested in. Now we need to check the length of the sequence because now we are interested in the sequence. We want to see how long the sequence will be. So we need a length variable to hold the length of this, of this sequence. So int length, and we will start from 0. Okay. So now how can we see how long this sequence will get? So we will have a while loop, and we will keep looping until we are seeing the next value in the sequence. If we are at 1, we want to see, hey, can we find 1 plus 1? Then we can say, can we find, the 3? Can we find the 4? Etc. So while the hash set dot contains the num plus, you are tempted to say num plus 1, but that's not the case. We are starting at the value 1. As you can see, we said that the length of this sequence is 0, but that's not the case. I just wrote length equals 0 to make the implementation easier. But honestly, we have, the value 1, so we have a sequence that is starting at 1. So the length of this sequence at this point is 1. It contains the value 1. So what should we put here, right? Well, we can say we need to count the number that we are at. And since with the length is 0, we can say, hey, does the hash set contains num plus length? And we know that the length is 0. We know that num is 1, right? 1 plus 0 is 1. So we are saying, hey, are we containing the value 1 in the array? Should we count ourselves? And the answer is yes. So we can say, hey, so length plus plus. So now we have a sequence that starts from the value 1, and we are counting this one in the sequence. You can see length plus plus. So now the length is 1. And remember that num is also 1. We are checking the sequence that is starting from the value 1. Okay, so now the length equals to 1. Okay, good. Now we go to we keep looping. We say, okay, does the hash set contains num plus length? Well, the num is 1. Now what is 1 plus 1? Well, 1 plus 1 equals 2. Do I have a 2? Yes, we do indeed. So the length of this sequence will be incremented. So length will be 2. We go again. Now, does the hash set contain num plus length? Num is 1, length is 2. Do we have 1 plus 2? Do we have 3? And the answer is yes. So the length is incremented again. And we go one more time. Hey, do we have 1 plus the length, which is 3? 1 plus 3 is 4. Do we have a 4 in the array? And the answer is also yes. So the length of the sequence is incremented again. And now we go, hey, do we have 1 plus 4? Do we have 5? And no, we do not have 5. So we know that we just break from this sequence. As you can see, we have a space. We break from this sequence, and the length of this sequence that starts from the value 1 is 4. Okay, how can we, okay, we have this length 4, but we need to compare this value to something. We need to return the length of the longest sequence. So what we can do is that we can have a variable that will hold the longest sequence that we will return, right? I will call it int longest, and we'll start at 0. So now when we break from this while loop, as you can see, we just have a sequence with length 4. We need to compare it, right? So now the longest, right, will be basically the maximum between two values. So math.max, we are comparing the longest variable that we want to return with what? Well, with the length of the sequence that we just finished, with length. And the biggest will be stored in longest. So now longest holds the value 0, and length hold the value 4, because the length of the sequence generated by the value 1 is 4. What is the maximum? The maximum is 4, so longest is updated to 4. So this is the approach, but let's continue and see what happens. Now when we advance to the number 2, what happens? The only way that we want to check the sequence that is starting from 2 is that if 2 minus 1 is not present in the array. And we see 2 minus 1 is 1. If the hash set does the hash set contains the value 1? The answer is yes, which means we will skip all of this. We are breaking from the if statement and we are going to the next value. Now we go to 3. But 3 minus 1, which is 2, is present in the array. So we again break. We go to 4. We notice that 3 is present, so we break. Now we go to 100. We notice that 100 minus 1, which is 99, is not present in the array, which means we are interested in the sequence that is starting from the value 100. So we go inside on the if statement. We are interested in this sequence, and let's start from 0, we said, and let's see. We want to count this 100 in our sequence, so we said, okay, 100 plus 0 is 100. Do we have 100? The answer is yes. So now the length plus plus. We have a sequence of length 1 holding the value 100. But now we say, okay, do we have 101? The answer is no. So we break from this while loop and we compare the longest that we have with the length of the sequence that we just finished. Which is greater? 4, which is longest, or the length, which is 1? Well, 4 is greater, so we do not update longest. And we do the same approach with 200. So at the end, just return longest, and that's it. Let's run the code. So let's submit. Okay, so let's look at the time and space complexity. Starting with the space complexity, we see that we are using hash set that will contain the element of the array. Assuming that the array holds n numbers, so the space complexity would be a big O of n. Now looking at the time complexity, from looking at this you might think that this is big O of n squared because we have, you know, a while loop inside of a for loop, right? But note that the only way we go into the while loop is that if the num is not present in any other sequence, as we discussed, right? So the time is big O of n as well. Let's look at something quickly. Let's say we have 1, 2, 3, 4 and 5. If we start at 1, of course this for loop will go through all the numbers, right? And now we say, okay, we go to the 1 and we check, do we have a 0? The answer is no. So we will have a sequence starting from the value 1. And we say, okay, do we have a 2? Do we have a 3? Do we have a 4? Do we have a 5? Do we have a 6? No, we break and we have this sequence. Now we go to the 2, right? But we notice that we have a 1 inside of the array. The 1 is present. So we are not interested in the sequence generated by the value 2. And we break from this whole if statement. We skip 2, we go to 3. Same thing, we skip 3, we skip 4, and we skip 5. As you can see, we did not go through those sequences. And this is why you see big O of n. So this is the key of the problem, this line. I hope you guys enjoyed the video. Best of luck to you and see you in the next one.